These next diagrams here get a little more complicated, but again, you want to go back to those basic rules that we learned and we'll be able to solve them. So in this first example, I see a lot of angles going on here, a lot of specifically inscribed angles. A word of caution here, a lot of people think that if there's an angle in the middle of a circle somewhere, it's a central angle. So like thinking angle C here is a central angle is not correct. You will see clearly the bolded dot or something to represent it as the center. For example, here, point O is the center of that circle. This is clearly not the center, so angle C is not equal to the arc it intercepts. So I'm gonna have to do a little work instead. Now I'm starting with A here, and I see that angle A is inscribed, so the rule says it's half of the arc that it intercepts. Now, if I look at the arc it intercepts, again, take the two legs and extend them through the circle, boom, here and here, that arc is 118, so 118 divided by 2 is 59 degrees. Great. As I keep going here and I look at B, I see something very similar happening. B is an inscribed angle. If you extend those legs, it intercepts the exact same arc. 118 divided by 2, again, is 59 degrees. That's two answers real quick. Again, using that idea of two inscribed angles intercepting the same arc means that they're equal. When I look at C, I'm gonna have to come back to that because again, I know it's not a central angle. I don't really have enough information. So I'm gonna come back to that later. Let's jump down to D. D is this right here. Extend angle D, the inscribed angle, and I see it intercepts that little arc of 80 degrees. So same thing, 80 divided by 2 gets me 40 degrees for D. And you're gonna see a pattern. What do you know? Point E up here, or excuse me, the angle that is labeled with E, also inscribed, trace it down, it intercepts that same arc of 80, so also 40 degrees. Now that I've filled all those in, I'm gonna come back and say, all right, what's the deal with C? C is this angle right here. Again, still not central, not inscribed, but I'm gonna have to use another rule that we know, that is the fact that the angles of a triangle make 180, the triangle sum theorem. Since B is 59 degrees and D was 40 degrees, I know that 180 minus 40 minus 59 gets me that angle measure of 81 degrees for C. So not using the rules of a circle so much, but using the rules of a triangle. The next problem is a great one because it incorporates everything we've been talking about. Inscribed angles, central angles, and arc measures, all in one diagram. So it's about keeping it straight. I'm only given angle at point A is 27 degrees, and it's clearly inscribed because the angle, the vertex of it, is on the circle. So the first thing they ask for is arc BC, which is here, B to C. That arc is intercepted by my inscribed angle of 27 degrees. So 27 times 2 is 54 degrees, and that is the measure of arc BC. Great. Once I put it in there, I might need to use it again, so that's why I wrote it in there. Next thing they asked me for is the measure of angle BOC. When you trace the angle BOC, that's the central angle right here. That was the first thing we learned about, and the central angle is equal to the arc that it intercepts. So this arc angle right here is 54 degrees. Let me fix that. Same thing, equal to the arc it intercepts. Next, ABC. So arc ABC from A to B to C. That is the top half of the circle, and half of a circle is 180 degrees. All right, now they're asking me for AB. So let's switch up a color. AB, arc AB goes obviously from A to B. Great. I just told you that ABC was 180, half a circle. If this part here is 54, then AB is what remains to make 180. So 180 minus 54 degrees gets me 126 degrees. Great. Angle AOB, AOB, that's a central angle with the vertex here. They're asking me for this angle right in here. Well, if I just told you this arc is 126 degrees, the central angle that intercepts it is also 126 degrees. These two here are very similar to these two here. It's the arc and the angle that intercepts it. Last part we got to get a little creative with again is ABO. That angle ABO is this angle right here, this little one. And that could get a little tricky, but think about what we did over here. A triangle makes 180. And if I know two of the angles, I know that they have to add to 180 with the third angle. So 180 degrees minus 27 minus 126 gets me another 27 degrees. One other way that you could see this, sorry, that color is not great, is all radii are congruent in a circle. So this AO and BO have to be congruent. So that's actually an isosceles triangle up there. Another way to see how we prove it.